The first thing that you want to do whenever you encounter a performance issue is almost always to profile. This will save you a lot of time in the long run. You have no need to randomly try and see what works. You don't have to rely on the telemetry you get from your FPS count and device usage. And you can identify bottlenecks, for example, if it's CPU bound or GPU bound, what draw calls are heavy, pretty much instantaneously. There's no need for guessing. And for example, you can also get really good A/B testing since you get to know what works, but also why. So just to give a rundown of what profilers you can work. First and foremost, we have the QML Profiler. This is something you'll want to do when you're running a Qt Quick 3D application or any QML application for that matter. It will help you find bottlenecks or hotspots for QML code. You can find out where Qt Quick 3D is working and how, and also what potential optimizations you could find there. For example, shader caching or texture uploads. You can use it for that. Moving on, if you have Intel hardware, you can use Intel Graphics Performance, which is very useful. It gives you detailed metrics on draw call timings and how the frame is composed in general. Additionally, you have VTune, which is good for CPU debugging. It shows, for example, the hottest code path in a flame graph style. Then we have Nsight Graphics for NVIDIA GPUs. Also gives really good metrics for draw call timings, but also actually gives some good shader debugging as well. For AMD, we have AMD GPU Profiler and AMD uMicroprof. For ARM, we have Performance Studio. This is especially good if you're using mobile or embedded hardware. Their documentation is also very good. And then finally, we have RenderDoc, which is generally used for debugging your 3D application, but it can also provide some timings. And of course, it's an industry standard. So you'll find a lot of documentation for it. So just to give a few images here, some screenshots. This is the QML Profiler. Here, for example, you can see the length and amount of Quick 3D calls, such as mesh loads, generated shaders, and you see those across times. So for example, here you see those two blocks showing shader generation, which would, for example, be a possible optimization opportunity that we found straight off the block. Additionally, the QML Profiler also comes out with a flame graph. This you can find out which code paths are hopped and what's running along with what's worth optimizing. And then this is a picture of the GPU Trace Profiler. It's an example of how you can debug your shader code. In this case, you can see it as SPIR-V code. And in the bottom right corner, you can see the shader hotspots. And this way you can, for example, find out which parts of our shader could use optimizations. So if you want to take one thing away from this talk, it would be to always profile. Profiling is the best way to figure out what optimizations to do.